All right, so algebraic expressions. And I know we just did a review unit, which is probably going to seem a lot harder than the start of this unit. But don't worry, it starts moving. Then it's like going downhill and running. Sometimes your body can't keep up with your legs and you're running downhill and you face plant. Just make sure you can keep up with your legs, okay? Comparing pizzas. Pizzeria sells a rectangular 18 by 24 inch pizza for the same price as its large, round 24 inch. If both pizzas are the same thickness, which option gives the most pizza for the money? I just got to figure out which is the bigger pizza if they're both the same cost.
How will we figure that out?
Let's find out how we figure that out. Now look it. 2 Sundays ago, I had family over for my daughter's birthday, and I ordered pizza. And you know, Mr. Maloney actually got on social media. I was like, oh my God. He's like, I hope you got the round one. It's the same because you actually get more pizza that way. I said, I actually have a lesson for that same thing in there. So of course I know. So all you guys are like, I'm hungry. Well, if you spend your money smart, you get more food. But hey, you know, it's not real, right? The numbers are all imaginary. It don't matter. So let's look at our rectangular pizza. It is 18 by 24. So how do I figure out the size of that? I multiply them together. I find the area. I don't need to find the volume because they're both the same thickness. Okay? So what is 18 times 24? 432. That is square inches of pizza. That's okay. It's all right. It's all right. It's all right. Now we are going to look at the round pizza. That is 24 inches. That means, here's the middle, it has a diameter total of 24 inches. So if this is the area of a rectangle, how do I find the area of a circle? Pi.
Yeah.
It's pi r squared, which in our case is pi times. Thank you. Thank you for not saying 24. The radius is 12. It's half of the diameter. So that is 12 squared. Now, in your calculators, don't use 3.14. Stop it. There is actually a pi button. Is it above the caret, the exponent in blue? All right. Do pi times 12 squared. You do pi times 144. You know that's 12 squared. But I always let the calculator do all the math work for me. Even me. Because it's easier. Because you can make a mistake when you're trying to do things quickly. So, what is pi times 12 squared? 452. Give me one decimal place. Round it. 0.4. It's 0.3 what? 3/8, which means we'll round up to 0.4. Inches squared. Which pizza's better to buy?
The round.
The round one. You're paying the same price. Why would you not have another 20 square inches of pizza? Why would you not have another 20 square inches of pizza? Yes.
A round pizza is not the same.
It does not. That's why they don't have the same formula to figure out the area.
It don't like you eat more. It don't eat more pizza. Like you have like a sheet pizza here. No.
Well, a sheet pizza might be bigger than that 18 by 24. All right. So this is obviously more pizza for the money right here, the round one. The round one. All right? Easy. Easy. Let's talk about another Italian guy. Galileo. He would spend his time rolling balls down an inclined plane, and he would record the distance versus the time. Okay. Here's my distance. There's the time. Pay attention. All right? This is what people that wanted to educate themselves did. No, that's what perverted people did. What he did was actually get a timer. I think one of those kitchen ones. They have it back. The little thing. They did have that. You probably just sometimes I go, oh, 1, 2. That's to reveal you're not being consistent. Okay, so what I had to do is he rolled the the balls down the inclined plane, and he figured out after 1 second it was 0.75 inches away from the beginning point. And for 2 seconds, it was 3 inches away, and so forth. And it got all the way to after 8 seconds, that was 48 inches away from the starting point. Okay? It's nice to have a table of values, because from a table of values, we can find what? We can find a graph, but the graph is based on what? Don't have a table of values. An equation. An equation, right? So first of all, let's look at this, and let's see if we can kind of guess what this graph might look like. Okay? Let's plot these points. All right? So we will call time is almost always our x value. Okay, so distance will be our y. This is our x-axis. This is our y. We know that time has to go to 8 seconds, right? So let's do this the easy way. Let's cut that in half. We know 0 is at the origin. Halfway between 0 and 8, I don't know, maybe right there, that's 4. Half of 4? And between 0 and 4 is 2. 6 is halfway between 4 and 8. So I go to that halfway point, I make a 6. And then I 12 a mark in between. 1, 3, 5, 7. That's the easiest way to do it. And I know my distance has to go to 48 inches, but I would just call this 50 inches. Okay? That's 50. Starts at 0 again. Half of that is 25. All right? Half of 25, that's 12 and a half. Let's call it 12. Half of that's about 12. Okay? Half of that's about 6. Half of that's 3, and so forth. In between 25 and 50, since we're going by 12, we'll call that 37. Okay? And then in between that mark should be 6, right? So this will be 31 and 43. Somewhere around that general area. The gap between 12 and 25 is amazing, but, you know. We could have put a 6 between there. That would be 18, wouldn't it? It should be, if we're counting by 6s. Now, let's start plotting these points. What do you think this is going to look like before you even start plotting? Straight line? Going up? Straight line? What do you do? Yeah, it's going to curve up. It's not going to be straight because the distance between these values, that's 0.75. So the distance between this and this is that 0.75. No, it's bigger. And the distance between the next two just gets bigger and bigger, so it's going to go up faster. It won't be a consistent increase, so it can't be a straight line. We know we're starting at 0, 0. Bang. Do this one. I should just do a check mark. It's not an X. Boom. 1 and 0.75, which is like barely up there. Bang, that's done. 2 and 3. So go 2 and up was a halfway point. 3, it's about there. 3, and we go a little bit above 6. So 3, we're a little bit above 6 here. I don't know, right there. I mean, you can see it's starting to curve right now, and that's what it should look like. 412, 412, right here. 518, oh my God, 518 right here. Man, guys, we are doing wow here. 6 and 27. 6 will go a little bit above 25, go to 27 right here. 7 and 36. I go to 7, and I go, it's just about 37, we'll call it. Right there. And 8 and 48, that's almost at the top there. I mean, that is nice, perfect, nice. Bill, you counted really nice. Mario. Mario, I mean, what's this middle name? So what does it look like? It kind of looks like half a parabola or an exponential. It'll go up quicker. The farther you go down the x-axis, the steeper the slope is going to be, the quicker it's going to rise. So it kind of looks like half a parabola or an exponential, and it's definitely not a straight line. But this much, doesn't a straight line going up and to the right represent increase? Yes, it's the same increase all the time. It is not this case. Okay? Done. Bang. So Galileo came up with this formula, y equals k times t squared. How can I figure out what the value of k is? What? Go ahead, Ben. Well, t is time. That's right. And we said that's normally our x-axis, or x value. That's a terrible t, by the way. So distance has to be either y or k.
It's both.
It's y.
I thought this was, oh, never mind.
So now, if we need to find k, what should we do?
Put an X in there.
We gotta do what?
Put an X out there.
Where? Put an X where?
Okay.
Put an X in for K? Substitute what? Values where? From the chart goes where?
Okay.
No, we're finding K. We don't have K.
So then you make it X. So the numbers are Y.
Hold on a second. Would you like to make a comment that's relevant to the situation? No. Okay. What value are you going to put where? Okay, you're going to put time is going to go in for the T.
And Y, I'm going for Y.
And distance, which is our Y, will go in for Y. Now we have two values and one unknown. We can easily solve it. So we can take any one of these pairs. So we pick 0, 0, that's the easiest. 0 cancels everything out. Should we pick 0, 0? No. Why should we not pick 0, 0? It will wipe out the K. Obviously, there's a value for K.
412.
We can do 412, it's easy. But what's even easier?
3 and 2.
What's even easier than 3 and 2? 1 and 0.07. Let's explain why that's easy. Let's put 1 and 0.75. This has to be 0.75, correct?
Yeah.
We don't know our K. Our T is our 1. What is 1 squared? What's 1 times K? And what is K equal to? Did you have to do any math there whatsoever? 0.75 equals K. Now look at this, but I like 4 and 12. Dad, nabbit, throw in 4 and 12. Guess what? You'll still get 0.75 for K. But 2 and 3 just seems simpler. Dad, nabbit, throw in 2 and 3. You'll still get 0.75. If I threw a 2 in for T and a 3 in for Y, 3 equals K times 2 squared. What's 2 squared? What's 3 divided by 4?
I want to be.
K is a constant that won't change. It should always be the same no matter which coordinate you plug in there. So whenever we see a table like this, if I want to know what the K value is, I can plug in values. But what else can I just now say? What would my K value be in this table? And where is that located on the table? More specifically, it says right there. Whatever is across from 1 is always our K value. Always. Because this always happens. The 1 will make K times 1. And the Y, that's what K equals. So it is always across from your 1. Now, what if you don't have a 1? Well, then you plug in numbers and solve for it. If you don't have a 1 on your table, you plug in numbers and solve for it. Now that we know what K is, I'm going to give you guys 1 minute to find out the distance traveled of your ball rolling down an inclined plane after 21 seconds. You have a minute. So what do we got? What did you come up with? 2 decimal places. 330 point what? Well, let's see if that's correct. We obviously still have to use Galileo's formula. We know that we're finding distance. We have K now, that's 0.75, and they're asking us after 21 seconds, that's our time. Don't forget to square that, people. So it's 21 squared times 0.75. And just to check, you guys, I can say 21 squared times 0.75. That's 330.75, absolutely, all day long. That's it. Nice. Nice. So, I mean, that makes sense. This only goes to 8 seconds. If you were to come up with a number smaller than 48, something is wrong. Because after 8 seconds, it's at 8 feet. After 21, it should be way further. Now, what's my label? Inches. I said feet, but it is inches. Don't forget your label. It's not inches squared. It's just inches. It's a distance. It's one distance. All right? Not bad. Crawling in this Monday. Yeah, man. The percentage of females in the prison population. Y'all bad. Y'all bad. Bad people you females are. Now, can you guess what this graph is going to look like? All right? Anytime we have years involved, in order to make our equation not astronomical in size of numbers, we say this is year 0. This is 5 years after 1980. This is 10 years after 1980. This is 15 years after 1980, and this is 20 years after 1980. This helps us make a more manageable graph and more manageable equation in terms of number size.
Yes.
All right, if I would throw in 1,980 instead of 0, that definitely affects the equation and graph. So our x-axis, we normally say is time. Y is percent of females. It's not actual number of females. We don't have 3.8 females in prison. That is a percentage of the female population. 3.8% of the whole female population is in prison. Don't blame me for making this problem. It was in the book. Well, I mean, I take the problem out of the book. The problem that was in the book. Okay? So, let's take a look. 0. We know time has to go to 20, right? And it counts by 5s. That's nice. Halfway is 10. Half of that is 5. In between 10 and 20? No, it's 15. Very good. Good stuff. And it looks like we only go to about 7, right? 6.7 is the highest. Let's make it countable. Yeah, we can count by ones. You can go to 8, cut it in half, or if you do it nice, you go 1, 2, 3, 4, 5, 6, 7. Okay? 1, 2, 3, 4, 5, 6, 7. Let's start plotting points, shall we, children? 0 is at 3.8 on the y. So 0 on the x, 3.8, these are right there. That's done. At 5, we're at 4.4. That's the kind of in between 4 and 5. At 10, we're at 5.5. I don't know, that's kind of halfway between 5 and 6, right? That's done. At 15, we're at about 6. We'll call that about 6. And at the 20, we are almost at 7, 6.7, somewhere around there. What does that look like? What does that look like? And it looks like a straight line, like you have like a line of best fits. That looks linear. Yeah, but Visca, 1 point is off. Every point, bless you, is probably somewhere close to this line, if not on it. Okay? And why is that? Because it's human population. It's a percentage of the population. Okay? When we had the ball rolling down the ramp, well, gauge speed just keeps on going. Gravity works on it, pulls on it. It's the same. But when it comes to the situation here, if this were to go up faster and faster, I mean, where do you go from like 5% of the female population to like 45%? That's, that's craziness. I don't know. It's crazy. All right. So this looks like a straight line. Good for us. We figured it out. Can we come up with an equation? There are 2 ways to come up with an equation. You can do it algebraically, or you can put it in a calculator. Calculator. You already know how. Remind. You want me to send that remind? Yeah. Yeah. All right. If this is 0, 5, 10, 15, and 20, okay, I'm going to go with, we said it's a line, right? What's the equation of a line?
Y equals.
B is your y-intercept. When x is 0, that's your y value. What is that? Look at our table. When x is 0, what's my y value?
3.8.
Yes, that'd be correct. So this is your B. So right now we know we're plus 3.8.
Wait, I thought it was the y. No, you don't know the y.
That's your y value when x is 0. It's your y-intercept. It's where you cross the y-axis at 3.8. So I know I need my y in there. I know I need my x in there. So I got to find m. What does m represent? Come on.
Nice.
Slow. Slow. Nice, guys. Nice. Proud of your talent. Now, That's not that answer for the rest. Slope is change in x, or change in y over change in x, isn't it? You have 2 points. Can't you find slope? Yeah. So let's pick the first and the last. It's the change in y. So I go, my m is going to equal 6.7 minus 3.8 all over my change in x. That goes from 20 to 0 with those 2 points, doesn't it? 20 minus 0. So I have, what is 2 point, or I almost gave you the answer. What is 6? Yeah, 6.7 minus 3.8 is 2.9 over 20. Someone divide that. What do we get? It goes 3 decimal places perfectly, doesn't it? 0.145. That's your slope. 0.145. That's your equation right there. Now, is there another way to do this in the calculator? Yeah, you got to go to stat, remember, enter. You put this into L1. You put this into L2. Then you go to stat, calculate. You want me to do this with you once? No, that's good. As a reminder, I will. And we're going to see how close our algebraic comes to what the calculator gives us. If you need to write these notes down, don't do it in the calculator with me. Write the notes down as I do it if you forgot. So view the dash LCD, which is right here, bang. Someone's going to have to give me the coordinates. Now, but if I go to stat, edit, which is number 1, I enter in my values. I know my x's go by 5, 0, 5, 10, 15, and 20. What are my y values? The first one is 3.8. Does it go to, yeah, 4.4, 5.5, 5.9, and 6.7. Once I enter in my stat edits, then I go to stat calculate, which is the second on the top menu. See, I go boom. And then what do I want? Do I want a parabola? No. I want a line, don't I? So look what number 4 is, a linear regression. Bang. I just come down here and calculate it. Look at that. That's by the thousands. Didn't we come up with 0.145? They have 146. They still have 3.8 like we do. So that's off only by 1,000th of a unit, whatever that is. Right, so let's use the equation we came up with algebraically. Let's use this one, okay? And let's figure out what percentage of females would make the prison population in 2014. Now, I said that was a percent of the whole woman population. No, that's actually the percent of women out of the prison population. If there's 10,000 people in prison, then in 1980, 3.8% of that, 100,000, 10,000, what I say, is what they would. So you take about a minute and see if you can figure that out based on the equation we came up with, not the calculator.
Do you put what?
Okay. So we're going to use y equals our 0.145x plus 3.8. This is the one we came up with algebraically. What percent did you guys, what percent did you guys come up with? Give me one decimal place. What percent did you come up with as an answer? Anybody? 8.7. 8.7. So let's see if that's correct. What value? Obviously, we're trying to figure this out. So y would equal 0.145 times what value of x? Why did you pick 34?
Oh, you add 14.
Because 2014, yeah, I'll be okay. Because 2000, yeah, that's just bad. Because 2014 is how many years from 1980? 34 years from when we started. That's why this is 34. And if we...
I didn't know you just multiplied it all together.
If we take 0.145, multiply it times 34, and add 3.8, you get 8.73. I don't know. It's 8.73, which we will call 8.7. Very good. So 8.7, and that is what? Label? Percent. 8.7%. Simple, you know, one day one.